Hi everybody, welcome to our last lecture of the semester on 12.4, Properties of Logarithms. So the properties of logarithms, honestly, they're a lot like properties of exponents because logarithms act like exponents. If you remember, we could go back and forth from log form to exponential form, and so these logarithms, they act like exponents, which is kind of fun, okay? So there are three properties of logarithms that we're going to go over today. We have the product property, quotient property, and power property, okay? The product property says that if you have a log with any kind of a base, we'll just call it base A, of two things multiplied together, so that would be the product part of it, you can separate them with addition. So that would be the log base A of x plus the log base A of y. And if you remember our exponent properties, this is kind of the a to the x times a to the y equals a to the x plus y. Do you remember that a little bit? It's actually a lot like that, where you have two things that are multiplied. We can separate them with addition. And so that's what we're going to see here. So the log of a product is equal to the sum of your logs. Okay? The quotient property would be the what if you have a couple of things that are divided by each other? So that's the quotient. You can separate them with subtraction. Okay, so that would be, your a to the x over a to the y equals a to the x minus y. Do you guys remember doing that with exponent properties? It's the same idea. So these are things that are divided by each other. Then they can be separated with subtraction. Okay? Last one is your power property. So this is the log base A. Oh, we should probably summarize a little bit for that quotient one. The log of a quotient is equal to the difference of logs. Okay, and now back to the power property. We have the log base A of x to the r. And so this is where you have like an exponent raised to an exponent, and that meant that they were multiplied together. So do you remember having like a to the x raised to the y power, something like that, where you had an exponent raised to another exponent? Then you would multiply those exponents together. Do you remember doing that a little bit? It's the same idea. So now what we're going to do is multiply by that r. And typically we put it in front just so you're not confused as to whether the r is inside of the log or not. So a lot of times I'll put that in front. Okay? So it's r times the log base A of x. So the log of a number raised to an exponent is equal to the exponent times the log. Okay? You'll notice that we only have a product property, quotient property, and a power product property. We do not have an addition or subtraction property, okay? So if you have addition or subtraction inside your logarithms, tough luck. You can't do a whole lot with that unless you can make them into multiplication or division somehow. Like if you could factor them or something like that. Okay? So let's do a few. So writing logarithms in alternate forms, sometimes it's nice to be able to expand your logarithms, okay? So that's what we're going to do first. And all of these is we're going to start with one log and we're going to expand them into logs with just one thing in each, okay? Because sometimes that helps us to find like terms. Sometimes it helps us to be able to evaluate parts of our logs and things like that, okay? So it can be a really helpful thing. So in example one, what we really are doing here is we're expanding. Okay? And our goal with expanding is just to have only one term in each, or only one thing in each logarithm if we can help it. So, first one we have is log base 6 of 36x. So that's 36 times x. So since we have multiplication, guess which property we can use? It's the product property. So the product property says we can separate those with addition. So that would separate as the log base 6 of 36 plus the log base 6 of x. The nice thing is we can actually do this part. The log base 6 of 36, because there's just numbers there. If you think 6 to what power gives you 36, well, 6 squared is 36, right? So the log base 6 of 36 is really 2. So you could also say that this is 2 plus the log base 6 of x. Okay? So that's why we can do it, because now we just get a number, and then we have a log of x, which isn't so bad. Let's do another one. In part B, I have the log base 2 of 7/9. So this one, the 7 over 9, is dividing. So we have division, so that's the quotient property that we should be looking at there. And the quotient property says that I can separate if it's divided inside of a log. I can separate with subtraction. So that would be the log base 2 of 7 minus the log base 2 of 9. And 2 to some power giving me 7, it's not going to be a pretty number. And same thing with 2 to some power giving me 9, it doesn't work out nicely. So we're going to leave it exactly like it is. Okay? Let's do another one. The next one I have is log base 10 of 10 to the x. This one I have a power property. I have an exponent inside of my logarithm, which means that I can separate it by multiplying. So I can say this is x times the log base 10 of 10. And you know what? I can do the log base 10 of 10. So you're thinking 10 to what power gives you 10? Well, 10 to the first power gives me 10, right? So that means that the log base 10 of 10 is just 1. So then I just have x times 1, which would be x. Okay? Let's see, next step in part D, I actually have a couple things going on here because I have a square root and I have division. Okay? So let's see, the square root, if you guys remember, is really the 1/2 power, and the reason I'm thinking about that is because I do have a power property up here that I could possibly use. So let's rewrite it in that way first. So the log base 7 of, this would be m over n raised to the 1/2 power. Okay? So then I have a power on the outside of everything, so let's deal with that first. Unless you really feel like distributing and dealing with it second, as long as you deal with it, we're going to be okay. But I'll deal with it first since it's on the outside. And so the power property says that I can bring that exponent out front and multiply it. Okay? So that'll be 1/2 times the log base 7 of m over n. Okay? Then we can deal with the division, and so the division, we would use that quotient property and say that if things are divided inside our logarithm, we can separate them with subtraction. So now I've got 1/2 times, I'm just going to use brackets because I'm about to multiply by 2 logs that are subtracting each other. So that would be the log base 7 of m minus the log base 7 of n. And you can keep it like that if you'd like to. You can also distribute the 1/2 if you'd like to. So you could also write this as 1/2 log base 7 of m minus 1/2 log base 7 of n. My math lab should be okay with either format, but you never know. Sometimes it's picky. Okay? So if it's picky, let me know. But that's what that looks like. Okay? Let's do another one. In part E, we have lots of things going on yet again. We've got the log base 3 of the cube root of 5 over k squared t. So we've got a lot going on there. So in this one, we've got powers. We've got a cube root of 5, which is the 1/3 power. We've got a k squared, and then just a regular t. And then we also have a lot of division, right? We're dividing by the k squared and we're dividing by the t. So since the exponents are kind of inside, I'm going to deal with those second and deal with the division first. You guys ready? Good. So how you can separate this is basically if it's in the numerator, if it's on top, it's going to be positive. If it's in the denominator, it'll be negative because it's dividing by the k squared and dividing by the t. So that'll be the log base 3 of the cube root of 5 minus the log base 3 of k squared minus the log base 3 of t. And you'll notice whenever I was doing all of these problems, we kept the same base with all of our logarithms as we went, okay? Then let's deal with our exponents. We can use our power rule. So we talked about that the cube root of 5 is really the 1/3 power. So what I can do is use my power rule to multiply that together. So that'll be 1/3 log base 3 of 5 minus, with the k squared, it has an exponent of 2, and I can use the power rule on it as well. So that would be 2 times the log base 3 of k. And then we still have a minus log base 3 of t, and I'm out of space. But that's your final answer. Will look like that. Okay? So when you have more than one thing, do what we always do and just do one thing at a time, okay? Just deal with your quotient rule first or your product rule first. If you have more than one thing multiplied up top, then you'll have more than one thing added together, okay? If you have more than one thing in the denominator, you're going to have more than one thing that are subtracted, okay? And you can deal with those kind of product and quotient rules first, and then deal with your power properties second. Okay, so just do one thing at a time and just be careful. Alright, in example 2, what we're going to be doing is exactly the opposite. They start with more than one log, and we're going to condense into one logarithm. So this is called condensing. Okay, so we're going to go from a couple of logs to just one. That's our goal. And of course you can only condense if they are added or subtracted, if you can use the power rule, the quotient rule, or the product rule, and of course they have to have the same base. Okay, so let's go from there. In part A we have log base b of 2 plus log base b of z. Since they are added, I'm going to use my product rule, and I can condense that to the log base b of 2 times z. And that's it. Okay. For part B, I've got 3 log base z of 5 minus 4 log base z of 3. Well, let's go ahead and deal with the power rule first. So this would be the log base z of 5 to the 3rd. And that would be the log base z of 3 to the 4th. Okay. Then we can deal with our quotient rule because we have subtraction. So this would be the log base c of 5 to the 3rd over 3 to the 4th. If you would like to go ahead and do 5 to the 3rd, go for it. I think, if I remember right, my math lab actually likes to see the exponents. Since we started out with like a 3 and a 5, it likes to see where the 3 and the 5 went. But you certainly can do them if you'd like. You know, 5 to the 3rd is 125. 3 to the 4th is 81. You can certainly do that. But I'm not sure how my math lab is going to feel about it. I think, if I remember right, it prefers this way. So that's it. Okay, and a lot of these, as you guys probably know, it's a lot of practice. Just like doing exponent rules when we were doing exponentials. Same thing with properties of logs. Once you get these 3 properties down, it's going to be like second nature, and you're going to be just fine with them. But it takes some practice to get them down. So go slow. Use the properties. Don't use anything else. You only have 3, okay? So just use the 3 properties that we've talked about today to justify what you're doing. So good luck. Let me know if you have any questions or need any help along the way.